Okay, Assalamualaikum. This is HL IB Chemistry. So on this video, I'm going to explain topic 18.3 about the buffer solution. Okay, so what is buffer solution? Okay, buffer solution is a solution which has the ability to maintain its pH or resist the change in pH when small amount of strong acid or strong base is added to it. Okay, in other words, buffer solution must have an acidic solution to neutralize the added base and must have basic solution to neutralize the added acid. Okay, inside the buffer solution, it must have acidic solution and also have a basic solution. Okay, we proceed to the next slide. Okay, there are two types of buffer solution. First, acidic buffer solution, and second, the basic buffer solution. Okay, what is acidic buffer solution? Acidic buffer solution consists of weak acid, that mix with its conjugate base. Okay, so weak acid here will neutralize the acidic, the basic solution, and conjugate base will neutralize the acidic solution. Okay, how about the basic buffer solution? Basic buffer solution must have weak base and must have conjugate acid. Okay, so weak base will neutralize the added acidic solution, and conjugate acid will neutralize the added basic solution. Okay, so for the acidic buffer solution, as I said before, it must have a weak acid and its conjugate base. Okay, so conjugate of weak acid here is a conjugate base. Okay, conjugate base. Okay, so example, ethanoic acid and sodium ethanoate. So where is sodium ethanoate is come from? Remember that this is titration process. Titration. So what is titration? Titration is a reaction between ethanoic with strong base. So the product here is CH3 COO Na plus H2O. Okay, so this is sodium ethanoate come from. Alright, so what happened to the weak acid? Weak acid dissociate partially in water to produce ethanoate ion and hydronium ion. Okay, this is reversible reaction. Okay, actually this is reversible reaction. Okay. So what is meant by reversible reaction? Even though ethanoic acid dissociate into the ethanoate ion, but once it reverse, meaning that the concentration of ethanoic acid still high. Okay. Alright. So how about the conjugate of weak acid? Conjugate of weak acid or conjugate base. Okay. Conjugate base. Okay, so sodium ethanoate will dissociate completely in water to produce ethanoic ion and sodium ion. So inside the sodium ethanoate, okay, this is a conjugate base. Okay, this is a conjugate base. Alright, so concentration of ethanoic acid is high due to partially dissociate of ethanoic acid and due to complexly dissociate of sodium ethanoate. Alright. Okay. Alright. Now, how acidic buffer solution neutralize resist the change of pH. Okay. Okay. Now, part A, okay, what happens when the strong acid is added into acidic buffer solution? Okay, as we know, strong acid have hydrogen ion inside it. Okay, so this is aqueous solution. Of course, strong acid dissociates or ionize to produce hydrogen ion. Okay, hydrogen ion represent acidic properties. Okay, now as we know, buffer solution have ethanoic ion, which is this is conjugate base. Okay, so hydrogen ion will neutralize by conjugate base, which is ethanoic ion, and produce ethanoic acid. Okay, so hydrogen ion, it can reduce the pH value, but when the product change from hydrogen ion to ethanoic acid, the change of pH is not drastically. It's still reduced, but it reduced slowly. Okay, not reduced gradually. It's reduced slowly. Okay, the hydrogen ion, okay, come from the strong acid, and ethanoate come from a complete dissociation of sodium ethanoate. Okay, and the ethanoic acid, present the decreasing pH drastically. Okay, so even though the product is still acid, but this is weak acid. Remember that weak acid not affect much on the changes of pH. Okay, so better it produce weak acid rather than produce strong acid. So as a result, the concentration of ethanoic ion decrease and concentration of ethanoic acid increase, but this not really affect the pH because it just weak acid. Okay, class? Okay, second situation. How acidic buffer solution can resist the changes of pH when the strong base is added into it. Okay, so inside the strong base, it have hydroxide ion. This hydroxide ion will neutralize by weak acid, which is ethanoic acid, and produce ethanoic ion and water. Okay, so even though this is conjugate base, but it's still weak base, not strong as hydroxide ion, meaning that the pH not increase drastically. Okay, if the hydroxide ion is present in the solution, the pH scale will increase, but once the product are changed from hydroxide ion to ethanoic ion, which is conjugate base, the pH still increase, but it increase slowly. Okay, so hydroxide ion, hydroxide ion from the strong base and ethanoic acid, partial dissociation of weak acid reform the ethanoic acid. Okay, so even though the product is okay, from partial dissociation of weak acid. Okay, alright. Okay, so hydroxide ion neutralized by ethanoic acid from the partial dissociation of weak acid. Okay, so this one, ethanoic acid from the partial dissociation of weak acid. Okay, so this prevent the pH from increase drastically. Alright, because the hydroxide ion was neutralized by ethanoic acid. As a result, the concentration of ethanoic acid decrease, but concentration of ethanoic ion increase. Okay, but the increasing concentration of ethanoic ion not affect the changes of pH. So this is how acidic buffer solution can resist the change of pH. Okay, class. Now we proceed to the basic buffer solution. Actually, the concept is same. Okay. Okay. Now let's look at what inside in the basic buffer solution. So basic buffer solution is mixing of weak base and it conjugate of weak base. Conjugate of weak base here is a conjugate acid. Okay. So in water, ammonia dissociate partially in water. Okay, so it does dissociate partially in water, meaning that even though ammonia react with water, concentration of ammonia still remain high. Okay, here. Why? Because this is reversible reaction. This is reversible reaction. Even though it produces ammonium ion, but ammonium ion reform the formation of ammonia. Okay, that's why the ammonia concentration of ammonia still high. Okay, inside the buffer solution. Okay, now in water the ammonium chloride dissociate completely. Okay, dissociate completely. Okay, where ammonium chloride come from? Ammonium chloride come from when ammonia NH3 react with let's say HCl. Okay, so the product is ammonium ion. Okay, so inside the ammonium ion has ammonium. Inside the ammonium chloride have ammonium. So this is conjugate acid. Okay, conjugate acid will neutralize the basic solution. Ammonia will neutralize the acidic solution. Okay. Okay, proceed. Okay, now what happened to the basic buffer solution when we add the strong acid? Okay, so inside the strong acid have hydrogen ion. This hydrogen ion neutralized by ammonia to produce ammonium ion. Okay, so even though ammonium ion is conjugate acid, but the pH not decrease drastically. Okay, because it is just weak acid compared to hydrogen ion. Hydrogen ion will affect much on the pH scale, right? So this is how basic buffer solution resists the changes of pH when the strong acid is added to it. Okay, so as a result, concentration ammonia decrease and concentration ammonium ion increase, but pH not much affected because the reaction due to reaction of ammonia only. Okay, what happened when the strong base is added into basic buffer solution? Okay, inside the basic buffer solution, inside the strong base, it dissociate to the hydroxide ion. So this hydroxide ion neutralized by ammonium ion that come from the ammonium chloride. Okay, so when ammonium ion here is a conjugate acid. Okay, this is the conjugate acid. So conjugate acid neutralize hydroxide ion to produce ammonia and water. Okay, even though ammonia is basic solution, but this is weak base. Okay, so this prevent the pH solution from increase. The pH still increase, but it increase slowly when the product is weak base. Okay, so as a result, the concentration of ammonium decrease and concentration of ammonia increase. Okay, class, so that's all explanation about the buffer solution, how buffer solution resists the changes of pH. Okay, thank you.